Alright, I know some of you have found it a challenge to build a circuit onto some breadboard. It's a lot of new stuff that they're not used to. So here are some tips which will guarantee that you'll feel a little bit better about it. This is the breadboard that we are using and that is common. So if you can see, these are all metal that joins together, and the metal as well is joined together along this way at the top and at the bottom. And you will also notice that in the middle here there is a big gap, a canal if you like, where this side does not join to the upper side. So you've got two sets going this way and this way, and you've got sets going this way and the same thing down below there. So I'm going to put that back, and what we're going to try to do now is to build circuit 2. Now these are two useful things for you to remember. Here's a tip that you can use, which is some kind of a highlighter, and the other one is to follow the circuit in terms of the layout as closely as possible, because then you'll be able to see what's on the board, on the breadboard, and have an easier time trying to compare it to the circuit. So if you look at most circuits, they're drawn with the lower bit here as kind of the 0 volts of the ground, and the top bit here, which is the plus. So that in this case, for circuit 2, this will be the circuit 2 in your handout. So we have a battery or a power supply with the positive going up here and the negative going up here. We can also consider this the 6 volts going up here, or the 0 volts going up here. Now, a quick way of giving you some convenience for this is to use these rows here. Now all these rows are connected together, and these rows are connected together. So we have one set here, another different set here, one set here, and another different set here. And just to remind you as well, these are connected together, this one's connected together, this one's connected together, and the same thing down here, but they are separated by this kind of canal, so this is not connected to this. So just to remind you again, if I peel back the base, you'll be able to see this up here and these connectors here. Now what we can do is, for sake of convenience, we can call these power buses, and we will say that this will be the positive, the 6 volts or whatever voltage it is, and the one here, which is indicated by the blue, we'll call this the ground or the 0 volts or the negative, come to the same thing. But what we do is we take this top row here in all the drawings to be the positive bus, if you like, there, and this will be the negative bus. It goes to the negative, goes to the negative, and we'll take this row here as the negative, and that makes things a lot more easy to follow. The other thing is to use your highlighter, and this is the way that we used for very complicated circuits, so it's a good trick to start using with these simpler ones as well. So we'll consider this top and this bottom connected, okay, through there and through there. And now for circuit 2, we want to connect the diode in between. So if you refer to your reference book, the this part of the LED, okay, is a longer lead. It's the positive side, or the anode, and this is the cathode, which is the shorter side. So the anode goes to the positive. So this is the positive bus, or the positive rail. I'll plug it in there, and I will plug the cathode there to this row there. It happens to be number 55. You may be able to see that, but that doesn't really matter. Anything will do. The next one then we want to use is the 470 ohm resistor here, and here's a 470 ohm, and what happens is that we've got one end that's connected to this end of the LED. So now that we plug this one in, we can highlight this one off. Now we want to connect this one here to the resistor. So remembering that this row, all the holes are connected together, we'll plug that into any one of them, let's say here. Okay, and this other one will go So we've connected this here now. So this is connected to the LED, and the other end of it gets connected to the negative there. Okay, ignore this 15 volts is for another circuit. So this one now goes to the negative down there. Okay, and then this will go, this top part here, the bus will go to the positive of the battery, so we can plug in a red, and this one will go to a negative of the battery, we plug it in here, and using your crocodile clips you can just connect it in there. So there we've got circuit 2 connected very easily using the marker to keep track and using the row of holes or sockets going this way and this way. This one for positive, this one for negative. Right, so we're going to do circuit number 3 in your handout. This would be the water level detector in your handout. So we start with the same thing again, positive and negative. The positive bus plus 6 volts, positive bus would be up here, and the negative here, or the 0 volts or the ground, will be down here on this row. And we want to start building the circuits in between here. So start with positive and negative. I've highlighted that. First one that we want to use is the buzzer B1. So this is it. If you remember, if you check your reference sheet, it says that this is the positive side. The more positive is red and the less positive is black. So we've got this here. We also have the transistor there. This is also from your formula sheet, so that's collector, base, emitter, CBE. In the circuit, this is the collector, this is the base, and this is the emitter. And then we have the 10K resistor, which is here. So let's start. Now, this is the more positive, that's red, and that goes up to the top bus, positive bus. So I will plug this in there. When you doing this in the lab, please use the crocodile clip jumpers, okay, but I'm going to just plug them in directly here to save time for the video. But in the lab, please use a crocodile clip jumper so that you don't break off the ends. So the first one is B1 to the positive, so we'll plug that in anywhere along this row, let's say here. And the negative now, so positive again, we highlight it and that's connected. Now this side of the buzzer will go to the collector of Q1. So we can, let's choose one here, we'll say it's here, and it goes to the collector. So the collector is the leftmost pin. Okay, so we will put the collector, we'll just plug it in here. 3 rows left to right. And now we see that this side of the buzzer goes to the collector pin. Right, so we can mark that off as being done. Buzzer to the collector pin. The emitter now goes to the negative rail. Okay, and since we don't have such a long lead on the transistor, what we'll do is we'll use another jumper cable. Okay, the emitter, which is this one here, so anywhere along this row, let's say this one, will go to the negative, and we'll plug it in there. So this now goes to the negative rail, and this connector here, this jumper will be this connection. Okay, if you remember again, these are called nets, the places in between the nets, and where the 2 nets join together, it's called a node. Okay, the next net to do will be the base of Q1 there, and we'll connect that to this 10K resistor, one end of it. Okay, so base of Q1, that will be the middle pin. So this will be the middle pin there. I'll plug in there, and this is 10K, and I'll just plug it in here for convenience. Okay, so now I have connected this one here to the, I made this connection to the base of the transistor, and now this one goes out to the water sensor. And for convenience, I will just use a yellow cable, and this one will go up to the water sensor. Okay, now next we have this other end of the water sensor goes up to the positive. Okay, sorry, I've forgotten this one. So this end of it goes to the water sensor. I can mark that off as done. The other end of the water sensor will go to the top rail. So I'll just use this. I'll plug this into the top rail. So remembering that this whole row is connected. So these two wires now will go to the water as the sensor. So I can mark this off as being done now. So that's now done. And the final thing now is to connect the positive and the negative to the battery. And I can plug this to the positive, and this to the negative, and this will go to my battery or my power supply. Job done. So by using this, you are constructing a circuit which is very close to how this diagram is actually drawn. So it's easier for you to check, it's easier for you to build and to troubleshoot if something goes wrong. So that is circuit 3 done. Next we're going to do circuit number 5, which is the flashing LED circuit. And we use exactly the same principle. So here's the top rail going to 15 volts this time instead of 6. And here's the bottom rail, which is ground or 0 volts or negative. So positive and negative. We'll use the same thing here, positive and negative. First step again, let's get our highlighter. We've got R1, which is 33K, and R1 goes to the positive, and then the other side is connected to the rest of the circuit. So the first part here is we've got the rails done, and this end of R1 is connected to the positive. So I will use R1 and connect it to the positive. We'll choose this one. Okay, it doesn't matter which one you choose, that one looks convenient. Now this end wants to go to the rest of the circuit, so I'll just plug it in anywhere convenient. We'll just say it's there. Now next one is that we have the capacitor connected to this end of R1. So this net now is done, but now this is a node going up this way, and down to the emitter. So there are 3 ways, and you have to be careful that you catch all of them. So now from this end of 33K, we connect it to C1, the capacitor, 100 microfarads, to ground 0 volts or negative, depending on what you want to call it. For a 100 microfarad capacitor, this has the polarity shown. So this is pointing, this arrow is pointing to the negative, okay, which means the side with the waste is the positive. Positive goes up to 33K. So in other words, positive is connected to here. So I will use any row, any of the holes in this row. I would use this one, plug it in, and so this one is done. And now this lower one goes to negative, or the negative rail. So that's this pin here, and I'll plug it into the negative there. So this connection now is done. Now let's do the transistor. So this end, which is here of the resistor, goes to the emitter of the transistor. Remember again, this is collector base emitter. This is the layout for this particular transistor, collector base emitter. And so the emitter is this pin, and that goes to this node there. So emitter is this one here, and I will plug it in here this way. So now you're able to see that this emitter, this is the emitter, and it's connected to the resistor as well as to the capacitor behind it. I'll just turn it around so you can see it there. Emitter to the capacitor to the resistor. So now we can mark off all this, emitter to the capacitor to the resistor, all done. Next one, the base is not connected, so that's convenient, we'll leave that. And now the collector goes to R2, or the 1K resistor. So I've got a 1K resistor over here somewhere, and 1K goes to the collector. I just bend this down out of the way so you can see. Be careful when you're bending that it doesn't touch any of the other connections as well. So this is the 1K resistor, and that goes to the collector. Collector is the left hand side, so I can choose any one of these holes here in this row or this column, and I'll plug this in here. Okay, and I'll plug this in on the other side. So remember, there, because of this canal here, there is no connection between this column and this column. It's broken here. So I've got this side connected to, now I'll highlight it to mark it off. That's how it's done. Next, this end, or the other end of the 1K resistor, goes to the anode of the LED, which is the longer lead, which is this one here. So this goes to the anode of the LED, so I'll plug that in there, and the cathode of the LED goes to the negative or 0 volts or ground, which is this rail going horizontally, and I can choose any of the sockets, and I'll just plug it in there. So now I've got this one connected here and this one connected there. And again, we want to connect this to the power supply, so we can use the red to connect the top rail, black to connect the bottom rail, and now these will go to your power supply. Job done. Now we're going to do the light detector circuit using the LM741 IC, or integrated circuit. So now that you've started using these practices, it starts becoming easier to do more complicated circuits. I will just point out again, just to remind you, this is in your handout, and the IC, this form of packaging, has a notch there and the dot, and the notch facing this way, and the dot down there, which I hope you can see in the video, that always shows pin 1, and the pins are labeled anti-clockwise, if you like, or numbered anti-clockwise. So it's 1, 2, 3, 4, 5, 6, 7, 8. And this is the IC. Right, so same kind of thing again. We start with, again, the top rail here, and the bottom rail. So the top rail goes to the plus 6 volts. The bottom rail, which is negative or 0 volts or ground, is there. And same thing, we're going to use plus 6 volts up there, negative down there. So let's give that a try. The first thing which may be helpful is actually to start with the IC, to plug it in, so you have a sense of connecting everything to it in the right place. Let's move it just further down there. And pin 1 is down at this point here. Okay. Yes. Right, now I'd forgotten to draw the rest of the circuit, so good thing I caught that, and these are the pin numbers as well. So the first one here is the buzzer. Again, the red lead of the buzzer goes to the more positive part of the circuit, so this one goes all the way to the 6 volt rail up here. So B1 goes into anywhere in this rail here, and the other side of it goes to pin 6. So it's 1, 2, 3, 4, 5, 6. So we will put it there, and this will be the buzzer connected. So the buzzer, this end is done and this end is also done. Next one will be pin 7 going up to the rail. So I'll just use a random color. You could use red. Let's use red, I think, to keep things standard. So pin 7, 1, 2, 3, 4, 5, 6, 7 goes to the top there. So now we can show and we can mark off this is done. Then we've got pin 4, which goes down to the negative of the ground. So 1, 2, 3, 4, negative to the ground, and that goes there. So I'm using this rail here as the negative or the ground or the 0 volts, same thing. So we can mark this one off. Finally, well, not finally, next will be if we let's do this one, R1 and R2. So 33K goes to the positive, to pin 2 is my 33K resistor. It goes to the from the positive there. Okay, so that's one end, positive, and we'll mark this one off. And the other end goes to pin 2. So pin 2 is over here, 1 and 2. So pin 2 goes in there. Mark this one off now. Okay. So this net now is done, this net now is done, and it's not connected to this upper one, it's connected only to this lower line. So we've got a node here to pin 2, so that's done. Okay. Now this node, pin 2, or this end, node will connect the other resistor, which we'll use this one here. So this one goes to pin 2 there, this one goes to pin 2, 1, 2, and I'll choose another one, so this is also connected to it there. So now this one is done, and the other end of the resistor goes to the ground rail, which we'll put it there. Okay, so that's the ground rail, and now we've got this one done. Finally, this last bit of the ladder. So R3, which is 1 kilo ohm. This is my 1K resistor. Top goes to the positive rail. So we go here. That one's done. The other end of the 1K resistor goes to pin 3. So we want to connect it over there. So this now is a little bit far away, and pin 3 goes across, but that's fine. We will just use, let's use this row over here, and we'll connect this one here to pin 3. So we're using this jumper now to go to pin 3. 1, 2, 3, there. So now this one is connected to pin 3. This one's done now, and this node here, the node, because there's several lines join. Yeah, this is the net where it's just a line, and a node where several lines meet together. This end now goes to the LDR. So this is the LDR. One end goes to here. So plug this in there. Right. So this net to this node is done, and the other end of the LDR goes to the negative rail. I'll plug that in to the negative rail, and now this end is also covered. So it looks like I've completed my circuit. All I need to do now is to connect my positive to my power supply here and the negative to the power supply here, and you've got the circuit running. So that is the IC circuit all done. If you found it useful, don't bother liking this video. Just make sure that you do this yourself, do it several times, do it without following the step-by-step things, and make sure that you are confident in getting the circuit built.